Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC but do everything DIY. And today we are continuing our installation of this split system water source condensing unit. In the previous video, I have the video of actually installing this, the water lines, the electrical, the gas lines. And what we noticed was that when we did the pressure hold with nitrogen, we had a leak. Thank you to everyone tuning into Jumperman Tech. In my previous video, we installed this condensing unit. It is a work of art. It was seriously a hack job installation prior. We redid all the water lines, we did the gas line and electrical. We had stuff like this going on, or just hanging extension cords. Anyways, we charged the system with nitrogen. We pressure tested all my gas lines. The refrigerant lines were good, and it honestly is a beautiful thing. The issue was that it wouldn't hold, and we went into upstairs to the evaporator section, and we found the flare nut on the expansion valve leaking. We tightened the flare nuts on the expansion valve and it seemed to stop leaking. We didn't see anything after we pressure tested it and checked with nitrogen, but then we ran a vacuum for a long time. Here the gauge is actually still connected to the system. We ran the vacuum for a long time. I had a micron gauge on there. I did bring it down to about 900 microns. Then I closed the manifold just to see what would happen. And it just kept rising and rising and rising to the point where we actually don't even have a reading anymore on here. Try to turn this on. What happened here with this thing? See, we have an OL reading. So we went to 5,000 microns, and then we just lost the reading in general. So that was telling me that, you know what, we must still have a leak on there, maybe something really tiny on that flare nut. So my plan was to actually get rid of that expansion valve, get rid of those flares, because when it goes into defrost and then cools from hot to cold, the flare nut expands and contracts and eventually starts to leak. That wasn't the first time I found a leak on that exact system in the same exact place. So that's why that was the first place I checked. So instead of those flare nuts, my plan was to braze on a new expansion valve. But guys, we have something interesting here. I did this job on Friday, all right? I did this job on Friday. I said, you know what? I don't want to start this brand new system with a leak in it. So I left the gauges on. Even the pump still connected there. Look at this, guys. We're still in a vacuum. Kind of blowing my mind right now. We are still in a vacuum, but we're scheduled here to change that expansion valve. We're still gonna do it, but it looks like that did it. I just wonder why we're not getting a reading on our micron gauge anymore. I know the battery on here is a little low. It shows 3 out of 4 bars, but still. Thing is, we still have a vacuum. Also, it took a long time to get down to 900 microns. I'm just wondering if there's just a bunch of stuff inside the pipes that's just making it hard to vacuum. Who knows? I know just by looking at some of the pipes, nobody was running nitrogen through it when they were brazing. We have so much carbon in here. I just seriously wonder. But anyways, I picked up a couple new goodies at the supply shop. I got a new regulator for my turbo torch, and I picked up another nitrogen flow indicator. We're gonna attach this to our nitrogen tank, and then we're gonna attach this to our regulator, so when we braze that valve, we're gonna flow nitrogen through the system, and this is the professional way to do it. Here's my nitrogen tank and my old regulator. Man, this thing is just all busted up. These gauges are broken, and it's just time for a new one. Time to upgrade. Quick note, guys, so right now I have this micron gauge on the high side of my manifold. I typically have it on my low side. The reason I switched it was because when I had it on my low side, this thing was auto ranging like crazy. Usually it's like a steady flow downwards, you know, the lower microns the better vacuum. but when I was running it, it was just jumping up and down a lot. Once I put it on this side, it was kind of just more normal, so it was just slowly, gradually coming down. Leave a comment below if you guys have any input on that. Could it be from a low battery? Could it be a bad micron gauge? I don't think it's a bad micron gauge, as it's been working just fine. It's fairly new, about a year old, and at the same time it was gradually coming down when I had it on this side. If anybody has any input on that, I would love to hear it. Let's go upstairs and drop the blower section and remove that expansion valve. All right guys, here we are in the refrigerator. Dear Lord, they got food in here. They just put some ice in here. That's not even dry ice, that's just like regular ice. Stuff is not even covered. Oh man, that's nasty, bro. Anyways, we gotta drop this cover right here, and the expansion valve is inside. Look at that suction line. That is the ugliest insulator. It is with tape. Oh dear Lord, man. Oh my God. All right, so the power is off here. This section up here inside the box has its own power source, and then the condensing unit downstairs has its own power source. All right, drain is out of the way. Let's take off the screws here. Okay, bring that down. Alright, what's up, man? Alright, here, lower section's down. What's up? Unplug this. Unplug this. Here's our expansion valve. Alright. Broke the vacuum. Yes, sir. Alright, that side's done. And then we have one more here to loosen up. Awkward angle, man. There we go. Alright, let's loosen this up. That side is out. Loosen that up. This is a thermal expansion valve, also known as a TXV. Thermostatic expansion valve. Then over here we have the sensing bulb. As you can see, it's attached to this line. Let's go ahead and loosen that up. Right there. Right there. Now we can slide this out. Right there. The TXV is officially out. Fortunately, usually there's a sticker here and it tells you the information on this valve. There is no information here. We're just gonna have to match up the body with the sizing and go off the compressor information. I know it's a 1/4 horsepower motor. We're gonna have to get a 1/4 horsepower TXV. We're using refrigerant 404A. Couple important things to note. And we're gonna get rid of these flares, get rid of these flare nuts, and I'm gonna braze my connections. This stuff is gross. Let's go ahead and match this up at the supply house. All right guys, I got the new expansion valve. This one doesn't have an angle, it's straight. And we emptied out the box in here. Also, behind here, I opened up the top so we can vent, because I'm gonna be lighting a torch up in here and I don't want to get smoked out inside there. So as far as right now, I'm gonna have to get rid of this. This is our 1/4 inch line. This is our 3/8 line. 1/4 inch goes here, 3/8 there. It's gonna be configured just like this. Let's go ahead and get it inside there and repipe this a bit. Cutting out these flare nuts right now. This line is done. Now I'm just cutting this guy out. Alright, I'm using wet rag, heat blocking putty. That's the blue stuff you see around the valve. Everything was sanded down. So 1/4 inch coming in, then comes out to 3/8. I also managed to get a fireproof cloth over here. I kind of just stuck a pipe in through there and tucked in that side. Hopefully it holds and we don't melt anything. We're gonna have to go downstairs and start the nitrogen. All right guys, I got everything set up downstairs. I just wanna set up the nitrogen. So there's a new condensing unit, everything looks nice. We redid all the electrical, so everything is with BX. Everything looks nice and professional. Here's the new lines. The filter dryer. I'm not gonna change the filter dryer just because this is brand new. I usually do the filter dryer last, but let's just get this thing in there. This thing has never been used. New sight glass. Everything is great. So I got both of these service valves open right now. They're cracked off the back seat, to be technical. I got my high side connected here. High side hose from the gauge. So nitrogen is gonna flow through here, through the high side, go through the valve, and then come out, and then the air is gonna come out. The nitrogen is gonna come out through here. So like that, we're gonna cycle nitrogen through the system. Right now, see, this is the setup. This is the old regulator actually. I already had it set up, and this is the regulator. If you can see, there's a little orange ball inside there, and it's all the way down. When you're between this range here, it's right there, the braze, it says 3 to 5 SCFH. Once I open up my manifold, you're gonna see this ball rise. It's gonna start floating in there. Right now, it's all the way on the bottom. I already had it set up, so we're gonna open this. Pay attention to that ball. You see how it's not all the way on the bottom anymore? Let me get my light right. See how it's kind of floating in there? Just putting my hand there. Got a little bit of nitro passing through. And that is looking good. Let's go upstairs and light this place up. Let's do this. Alright guys, looks like I got it. It was a bit difficult. Ain't the nicest braze, but let's leak check it. Alright. Charge through the high side. Pressure's coming up on the low. Let's get this to at least 300 pounds. So look at that, that gauge might be messed up. I use Cal Blue micro gas leak detector by New Calgon or New Kalon. Not sure how you pronounce that. I'm just gonna basically spray our joints. Make sure we don't see any bubbles. Tight space. Alright. Sometimes I run my finger through it. Okay. Let's give it a few minutes, but it's looking good. Alright guys, actually this is looking pretty nice. Looks a lot better. Also, you know that thermal putty is awesome because look at that. You can still read the QR code. Even the paper didn't even burn. Man, that thing is official. Alright guys, that's a beautiful thing. I'm gonna leak test it one last time just to be sure, but I know it is. And we're gonna dump the nitro and throw this thing in a vacuum. Alright guys, that's the final product. Right there, everything's nice and safe. Gets rolled over and it's strapped. Nice and tight. You want that sensing bulb very tight. I disassembled the hoses from my nitrogen tank and then opened the manifold, dumped the nitro, Hooked up my vacuum pump. Says we are at 30 inches mercury vacuum on that side. Got my micron gauge connected. We're at 5,500 microns at the moment and dropping. Alright guys, let's just let this run for a little bit. Let's see what happens, but it's definitely coming down. Alright guys, we're back at the blower section. I insulated the sensing bulb. Everything is nice and safe, and I put a little bit of insulation on here so this pipe doesn't rub out against the metal. And for this application, I used cork tape, premium cork insulation tape. Everything's nice and prepped. Let's go ahead and hang this blower section and put the food back. Seafood, man. Oh Lord. And we're up. Alright, we just turned on the power for the fans, the blower section. Both of them are running. Everything's good to go. We are back downstairs. I want you to look at that. 553 microns and coming down. That is a beautiful reading. I'm much more confident in that. I noticed when I started this system's vacuum, this thing pulled down nice and smooth, as it should. Just kept gradually coming down, and we definitely didn't reach anything like this. I had the system in a vacuum for about 2 hours now. We took lunch, organized our tools, got rid of stuff we didn't need, put up the cover upstairs, make sure the power's on, and we're pretty much where we need to be now. I got a fresh tank of 404A. We're gonna stop this vacuum, and I have a refrigerant scale here. I have no idea how much refrigerant to put in, but we're gonna go with our water temperature. We're gonna go with our sight glass, and we are gonna weigh it and see what happens, and we'll do what we gotta do. Here's a new condensing in it. Everything looks really cool. I actually used flexible hoses for the water line. Right there, that's the outlet, and over here, this is the inlet. Looks pretty cool. So I got that to go. Perfect for this kind of application. Then I started practicing with my bends, and this is my pipes. This is our liquid line. Everything looks really, really cool. Beautiful job. Let's stop this vacuum. So far I got 31.75 ounces, so I got about 2 pounds in here for now. Sight glass cleared up. Turn the power on, and we have a digital reading of the pressure in the circuit. Right now, I'm gonna make a separate video on how to set this controller. This is the Emerson unit controller. Let's go ahead and start the system up. All right guys, compressor started. We got a 60-pound, 65-pound back pressure, 100 head pressure. It's a water cooled system. Just want to let it run for a few minutes. At the moment, we're gonna have to adjust the water regulating valve, and we're gonna want to make sure our sight glass is clear. Right now we do have a little bit of bubbles in there, meaning we're not fully condensed yet, but I want to give it a few minutes. See the bubbles in there? You want that to be clear. I'm gonna give it a few minutes, but it's awesome. Look, it's reading the back pressure digitally. Man, that's awesome. What an upgrade. Let's give this a few minutes, let it settle out, about 5 minutes or so, and I'm gonna have to get that head pressure up for sure. So when I made a video on how to adjust a water regulating valve, I'm gonna link that in the description as well. But to keep things short, watch the spring. If you look at the spring, when it's all the way up, you're gonna have the least amount of pressure, and if you bring the spring down by adjusting the stem up top, you're gonna increase the head pressure. Alright, got an update. Our back pressure is now at 50 psi with a 225 head pressure. Watching this thing. Our sight glass is clear. We are fully condensed. And I also insulated the suction line. Pipe is coming through there. Oh boy, does that look good. That is a beautiful thing. I mean, look at this suction line. Look at this thing is in the wiring. Oh man, electrical tape. What a mess. A lot of these units are really terrible, and other suction lines are not even insulated. All right guys, quick update. Everything's looking good. We're just waiting for the thermostat to properly shut off this machine. Right now, our box is at 36 degrees. We want this system to range between 35 and 40 degrees, maybe something like between 36 and 39 might be good, but we're gonna watch for that. We got a clear sight glass. We got a beautiful new unit. Got all new proper connections for electrical. Got a digital controller. Man, this thing is cool. Man, I really feel proud on this job. It was definitely an amazing one. From here, we're just gonna wait for the thermostat to cycle on temperature. I'm gonna keep an eye for that, make sure the system turns on and off. And we're pretty much good here. If you guys haven't watched the original video with me replacing this condensing unit, highly recommend that. And we're gonna wrap it up here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. I'll catch you all next time.